talking about PIPSpro. Our QA software, again, it's a filmless and quantifiable TG142 QA solution. Allows you to automate and track the analysis of over 30 TG142 recommended tasks. Those tasks include the MV imagers, the cone beam CT, so not only the 2D imagers for MV and KV, but also the 3D cone beam capabilities of your LINAC. We have MLC QA tests, both image-based and log file-based. Image-based, including picket fence, multi-port test, and also leaf transmission tests, both inner leaf and inner bank leakage, easy to say. And then we also have our log file-based software, which is a leaf speed and reproducibility, repeatability tracking. And the nice thing about that is we actually cover each individual leaf. It's not an average over an open field, and I'll kind of talk about that in a little bit. Stereotactic module, which is basically an automated Winston Lutz. It allows you to bring in images of your Winston Lutz phantom, either like a cube or a pointer, or many different types of phantoms out there for this. We're vendor neutral, so it does not have to specifically be the standard imaging pointer. I know some of the LINAC manufacturers include pointers as well, but we have a couple of different stereotactic Winston Lutz pointers and phantoms that we offer, so we can talk about those as well. Radiation light field coincidence, talk about that also. Starshot analysis for gantry, couch, and collimator. And then we also have an IGRT, kind of it's a trending tool. There's no analysis done in the software. That's typically done with your imaging and your treatment planning computer for doing image registration and such. So we can track the 2D, and 3D matching of your phantom, something like our Mimi phantom, which we offer. And so, the nice thing about and the big thing about PIPSpro, it basically allows you to reduce downtime. It lets you kind of track and see if there's any downward trends or issues with any of your systems that you're monitoring with the PIPSpro software before it becomes clinically significant, and gives you that time to, if you see some downward trends of any issues within any of these tests, it gives you the opportunity to kind of get service personnel in there early before a stoppage of patient treatment happens. So it just lets you track and make sure that you can get those taken care of before it does become clinically significant. Going on, starting with PIPSpro, database management. The nice thing about PIPSpro is it can be a centralized system or a local system. It scales up accordingly to any size of enterprise. If you have a number of different hospitals under one umbrella, you can set it up to a single server, and everybody can access that server and the data from different sites. You can kind of see how things are happening at different facilities in your group, or as small as a single 1 or 2 LINAC site. Like I said, it's easily scalable for any type of situation. There's an easy department and user setup, and I'll kind of touch on that in a little bit as well. But we have a system manager, as you see in the lower left, that helps you kind of set that system up, and once it's set up, you're good to go. You don't have to kind of keep going back into things. So that kind of makes things very easy to track and set up for your facilities. Citrix server support for that enterprise-wide system capability. Again, that centralized database, so everybody can kind of see, the administrators can see what's going on at not only the single site, but if you want to have access to other sites, just so you can kind of compare and see how other sites are doing, or track everything, you can do that as well. And then the nice thing too is we have baselines that provide what we call quick selects, which give you direct access to your tests and specific results for those tests easily. Setup specifics, as I mentioned, our system manager allows you to set up your LINACs, set up your departments, set up your users very easily. The users can be set up with different levels of security. So you have a basic user that may be only able to do the testing, and then you have a higher level of security, say administrator level, that can set up Linux, can set up departments, set up users, and change thresholds for the system, etc. And the thresholds page on the right, everything is set up from as a default for TG142 recommendations, but those can be tightened or loosened as you see fit, very easily within the system manager. There will show, when you open up the software, there's always going to show you what we call the QA dashboard, and that shows you the last result of a specific test that were done. As you can see here, it kind of populates with the results and showing in not only different colors, green for a pass, yellow for a caution, red for a failure, but also shape-defined images as well for anybody with like color blindness that has issues or problems discerning different colors. You can also track those by shape. And it's quick and easy review, and that's toggleable on and off. Getting into the tests themselves, we have the planar imaging, both MV and KV, for the EPID and the onboard imaging system, and gives you automatically calculated results for spatial resolution, for uniformity, for noise, for contrast to noise. Gives you those color-coded results like you see here, which you have green, yellow, and red, obviously, like I mentioned. And then you get a nice resolution RTF curve for the results for your resolutions as well. So you'll see on the right you have the phantom image, and the software is smart enough to localize on each of those individual ROIs on the phantom and run the analysis automatically. And then utilizing a flood field below, we'll be able to find 5 points across that phantom for uniformity, and then the darkest and the lightest spots within the phantom image also for contrast. The cone beam test, 3D cone beam utilizing the CAT fan phantom, which is supplied typically by the Linac manufacturer, either Elekta with the 503 Phantom or Varian with the 504 or 604 Phantom. Then we also can analyze the 600 series of Phantoms for diagnostic as well. But those are a Phantom again manufactured by Phantom Laboratories, but included typically with a Linac purchase and a Linac purchase with cone beam CT capabilities. Also, and you'll see the CT results overview in the upper right, and that kind of just gives you a quick glance, similar to the dashboard that I just showed you, but more of a quick highlight than showing red, yellow, green issue results, pass, caution, and fail. And you can click on any one of those individual boxes, and it will bring up the specific test result, and I'll show you that. I'm going to jump into the software in a few minutes, and I'll just kind of run a few different tests and kind of show you the interface and such. But that's for the cone beam CT. As I mentioned, the leaf speed test utilizing the log files. We do travel speed. We do a segmented IMRT, moving window, leaf position, repeatability. So there's a number of different tests, log file-based tests we can do. And the nice thing about PIPSpro, and one of the unique things about PIPSpro, is that we actually look at every individual leaf. We don't do an overall leaf speed average. You can actually hover over each leaf and see what the specific leaf loss, or in some cases gain of the leaf speed. If some of the motors are overreacting, or some are slow to react, you'll see the results for each individual leaf. The image-based tests, like I mentioned, we've got a multi-port the picket fence test. We've got leaf position accuracy and leaf transmission test. So we've got that functionality as well built into the software. These are all phantomless. The only phantoms you're using typically for leaf speed is well, no phantom at all, I should say, because you're using log files or a phantomless imaging QA for the MLC tests. The radiation light field coincidence, we do have a phantom for that that's as part of the package, and that's our FC2 phantom. You can utilize it for 10 by 10 or 15 by 15 field sizes, and the phantom image will show the fiducials and at certain points within the phantom, and then the software will discern those locations of those fiducials, analyze them accordingly to the field size and light field size, I should say, that was set up, either again 15 by 15 or 10 by 10, and then report on those coincidence of the light field to the radiation field. And then there's also a central axis marker as well to check and analyze the crosshair position, the center of crosshair position of your LINAC to the from the light crosshair to the actual radiation field. Star shots, again, we do star shot analysis for gantry, collimator, and couch, EPID or film. Obviously, some of the geometries don't allow for using the EPID, so that's where film will come in handy. It's a one-quick analysis. You just click on the center, anywhere in the center of the star shot. The software will localize on the center, so it doesn't do perfect. Just kind of hit the bright spot in the middle, and the software will analyze and discern where the center of those rays cross, and then do the analysis automatically. The automated Winston-Lutz test, like I mentioned, you can utilize just about any type of Winston-Lutz phantom. We've got a couple different pointers like this here. This is our basic pointer. We also have one with micrometer adjustment, our 3D adjustable pointer, and then we also have a standard Winston-Lutz cube as well, which is just a small cube with a 6 millimeter ball in the center. So it doesn't have to be any specific type of phantom. Basically, I've seen some users do a ball attached to glued to the end of a stick, like a BB glued to the end of a stick as well. So it kind of is open to as long as you can get a ball in the center of the rotation, you can do the Winston-Lutz test. And basically, localizes on the edge of the field, and we can do fields for MLCs or cone-based QA, and localizes to that center crosshair, showing the green is the radiation center, and then the brown is showing the detected ball center. Even though it looks like the ball is not necessarily in the center, it does localize on the center, and then it gives you those 2D shifts for each image. And then calculating across those 8 images, it gives you the optimal shifts in 3D in your X, Y, and Z direction. One point of note is you don't have to have 8 images. You can do with as few as 3. It just gets more accurate the more images and the more gantry and couch angles you use. So it gives you that functionality for anywhere from 3 to 8 images. I mentioned the IGRT module, and this is more of just a trending function and kind of a tracking. So we've got our MIMI Phantom, which allows you to do your MV and KV imager perpendicularity, and so you can do your 2D matching and your 3D matching, get those X, Y, and Z deviations, and then enter those in, and then you can track that over time. And typically, it doesn't have to be our MIMI Phantom. There are other Phantoms available. We also have our IsoCube Phantom, which is similar in scope, but there's other Phantoms out there for this type of test, such as maybe the PentaGuide, that can be utilized as well. So again, we try to be vendor neutral and agnostic. You don't have to specifically use all our Phantoms for some of the capabilities, but we'd prefer if you would. But we understand that there are other availability to Phantoms out there. So But that's the IGRT module. So I'm going to jump into software real quick. Let me unshare very quickly and reshare on my software side. So as I mentioned, when you open up the software, the first thing that pops up will be the QA dashboard. And like I said, this kind of shows you the last result, the last date the test was done, what tests were done, what application they are, what tests they were, and what have you there. So that gives you just a quick overview of the last date of testing. And you can easily choose your different machines. Right here I've got the TrueBeam for Main Street Hospital, and you'll see here this display here. This is our PIPSpro dashboard. We also have a software, our QA database software called QA Pilot, and this allows you, by clicking on that, it allows you to push the data right into QA Pilot for quick reporting, quick analysis, quick storehousing of all your QA. And I'll kind of show you that at the end too. I've got a couple screenshots of the QA Pilot that you can kind of take a look at. But moving along in the software, I can go ahead and I can hide the dashboard or just click on the X and close it. This is our workspace here. As I mentioned, the system manager, this is kind of where you set up your divisions, your departments specifically. So if you've got a overarching group that oversees a number of facilities, you can set them up as a division. Then your individual departments. So here I've got Main Street Hospital. Users, this is where you set your users up, name, first name, last name, username, email, department. Here's your position, your security level, administrator, which gives you access to be able to do anything within the software, whereas a lower security level will only maybe allow the personnel to do the testing and not do any analysis, not do any trending, do any changing of any parameters within the system manager. Linux setup, pretty self-explanatory as well. I've got my different machines here. I've got a TrueBeam here showing 120 leaf MLC, multi-leaf collimator. Whether it's got a 2D or a 3D or a 6D couch, what my images are, etc. So quick setup there for each individual LINAC. Thresholds, like I mentioned, all the thresholds for the different test results are preset for TG142, but they can be loosened or tightened as you see fit by just going in and adjusting those numerical entries to tighten or loosen those parameters. And then finally, just control of the phantoms here. And the interesting thing the nice thing about our QC3 and our KV phantom, which is our QC3 is our MV-based phantom, and our QC KV, obviously our KV-based phantom, we have calibrated numbers from the factory specific to the frequencies that are put out by either Varian or Elekta. So they're kind of calibrated to their specific systems. And that's kind of unique also for our phantoms, that they are calibrated from the factory with specific ROIs. So that's quick and quick information on our system manager. I'm going to close that. I'm just going to do a couple of different. I kind of gave you a good overview, I think, of the different tests we do, but I'm going to kind of grab a couple and just do a couple of tests. The imager test, for example. Choose my quick select, and I'm going to maybe do a planar image, a planar QA of our EPID. So the nice thing about the software too is it always remembers your location of your images. So the first time you go to a specific directory for your images, it will remember that for each specific test. So here in this case, I've got my image here, and I've got my flood field, so I can go ahead and I can just grab those two and open those up. It will automatically take a look and kind of find those ROIs you see here by the blue circles. I can accept that, and then automatically will do the calculation and give you those results. So here's the phantom image. Here's that flood field showing you the 5 different points across the phantom for uniformity. my darkest position, my lightest position for contrast, and then my results page here. So I've got my my F50, F40, F30 resolutions, my uniformity, my noise, my contrast to noise, all in a quick view situation here, showing you that they're all passing because they're green. If there was a caution or a failure, you'd either see yellow or red on those as well. So, and then here's your MTF curve for the resolution also. So very simple, very quick, easy automated test analysis to give you that. And then you just need to, you can go ahead and save that over here, and it saves to the database. And then you always have the ability to check the history view to see those trends. You can kick out a report. You can export them as well in a CSV. So you have a lot of different ways to keep your analysis tools and your trending results accordingly. And as I mentioned, if we have if you have the QA pilot software, this can get automatically pushed into there as well. And I'll kind of again touch on that in a little bit. So that's the planar result. So I'm gonna save that real quick, and then I'll reset that. I want to just do real quick, show you, I've got to close that because I'm in the, I want to show you the cone beam CT module real quick. So again, I load that, it will automatically, it will open up the software. I think I have too many things open today. There we go. You'll see here I've got a couple of sample sets. Because I'm doing a true beam, I'm going to click on my Varian 504 Phantom. It again remembers where that directory is. I can open that up. It will automatically bring that phantom in. It looks for what we call the key slice, and that key slice is just the target area that kind of gives you the position of the start, and then from there it discerns across the phantom for the different tests. So I've got the uniformity and noise, the Hounsfield constancy, space resolution, geometric distortion, slice thickness, and low contrast tests as well. As mentioned, I can click on any of those here. I'm going to maybe take a look at the Hounsfield constancy. Here's my pertinent slice for that. And this is for the Hounsfield. I've got my 8 different materials, and you can see those in plugs around the perimeter of the phantom here, 1 through 8, showing you not only what the expected number was and the known number, but what the measured number was by PIPSpro, accordingly with the results. And again, here they're all green, all passing, so that's you're good to go there. If I want to take a look at a different test, I can go over here and I can pull that slice there, that drop-down menu. Say I want to look at my my slice thickness. And that'll be it'll be the same slice, because not only do you have your different density markers here, but you've got your step wedges here here in the 4 different spots for your slice thickness. So here I've got 2.5 millimeter slices. These are the measured calculated thicknesses of those slices, again close enough to be passing for all. So that's that's a couple sample of the cone beam CT tests. Then moving on from there, I don't want to save that. Don't need to. I've got some saved already. But if I want to take a look at my radiation light field real quick, I can again load those images. I've got either a 10 by 10 or 15 by 15. Take a look at my 15 by 15 today, and automatically, as soon as you click on what your image is, it will automatically produce that the results here, showing that my light field displacement in the X and Y direction, my jaw displacement or MLC displacement in the X and Y, or sorry, left and right, top to bottom. If there's any rotation, and what that phantom dimension is, either 15 by 15 or 10 by 10. And then my crosshair displacement as well. And you can see here I've got my radiation crosshair as measured, and my light field crosshair displacement as well. If I want to take a look at that image, I go down here and I can take a look at it, and you can kind of see what that image is. And the green line square shows you what was found to be the radiation edge, versus the red, which is the set 15 by 15 field edge for the light field, and that was set on the external surface of the phantom with your light field in your collimator. So that's the results for the radiation light field. Let me do one more. Maybe I'll show you the stereotactic, and then I'll show you the log file based, just in kind of reference of time. So similarly, you go and you select your 8 images, open those up, automatically comes in, automatically calculates on those ball marker and the center of the radiation field, gives you your shifts in X and Y, and using those 8 images, again, you can use as few as 3, but the 8 is going to give you a much more accurate calculation. Here's your 3D calculations over here, your 3D for your optimal shifts. So then you can make that shift accordingly with the couch to move to the optimal isocenter for stereotactic. So that's a quick and easy view of the stereotactic module. One point of note, the stereotactic module here is also available as a standalone module. So, if you're just looking for an automated Winston-Lutz test, this is also available on its own. And let's see, I'll probably maybe do the log file based as well. So the log file based, a couple different things you can do here. You get our Dynalog files coming in from Varian. So you'll see you've got a few different things. We've got step and shoot. We've got a modulated arc. We've got a sliding window. We've got a standard leaf speed test. We've got a repeatability test. The nice thing is you can utilize just a very basic leaf pattern. You can use actual custom patient MLC files as well. So if you have maybe a prostate plan or something with active MLC, you can test that as well. You can do what we call simple or complex, and then we also, for repeatability, we have a diamond shape pattern as well. So just for I'll do a leaf speed, and this kind of shows some typical failures. Open that up, and I can go ahead and I can just kind of play that. You can get a visual representation of what's going on. You'll see some of the cautions and some of the failures across the field for the different leafs. But then if I want to go ahead and calculate that over here, I can calculate it, and then I can see a visual representation of each individual leaf speed loss. And you'll see here, this is somewhat representative of what you might see on a MLC that might need some attention, obviously, because we've got your outer leaves here showing some significant leaf speed loss, which is kind of typical because a lot of times those outer leaves don't get exercised as much as the inner leaves, so they tend to stick a little more. Sometimes the motors, tend to have a little more issue on the outside ones because they don't exercise as much. But the inner leaves, like you see here, perform pretty well. And you can, like I mentioned, you can go ahead and hover over each one. So right here, leaf 41 has a leaf speed loss of almost 2 millimeters per second, which is still passing, but is approaching a cautionary position here. It's noted here that we have those thresholds set at 2.5 for a caution and 5 millimeters per second loss for a failure. So you can kind of see those as you see on the two banks. You got your bank B and your bank A. And then you see here in the upper left, this is what I call 10 worst culprits. So basically, these are showing you the 10 worst performing leafs across each bank, just to kind of give you a visual to see what's happening with the worst ones. So that's an example of the leaf speed. So do a quick save on that and reset. I want to do maybe a repeatability test. Oh, I got to get my I've got to load my repeatability. And you'll see that this is a different type of test. So is my repeatability, and you see it's a diamond shape versus just a single band of leaf movement. And this is what the play of that would look like. It just kind of exercises every leaf in different speeds and different positions. So there you have that. I'm going to go ahead and I'm going to calculate on that. This is just showing me there's new angles and leaf speeds. So just kind of an indicator that there shows a different set of leaves for this one. And this kind of shows you similarly, a repeatability differences here. And you'll see a lot of the leaves are right on speed. This one here, my mouse is kind of sticking. Lead 36, I only show 0.02 millimeter loss, so it's very accurate as far as what's happening with this set of leaves here. So that's a sampling of the leaf speed test, one of the MLC type tests we do. And then image-based tests as well. This is our, I'll show you a picket fence test for this one. Do a multi-port, just as an example. And there, within the software, one thing I didn't mention, for multi-port and then also for your Starshot, there is a compositing tool in the software that lets you kind of composite your images, because obviously you're going to do multiple images of the multi-ports and multiple images for the different axes, spokes of the Starshot, so you can kind of combine those and put those together in one image. But here you're seeing the images for the 5 different ports. You do see some fiducials here. This is actually kind of a leftover. We did at one point with our first iteration of the software, and you can still use it today. We have a Phantom that has 5 fiducials on, or 4 fiducials on it that get placed within the center of the Phantom, or the center of the field, and utilized. But we also have a Phantom list. We changed and updated the software a couple of versions ago to be Phantom free for this test. But you'll still see the residual Phantom image here. But anyways, there's showing you the different ports, the different positions for your 5 ports, and then your results here showing you your left bank at 70, your left bank at 40, your left bank at 10, your left bank at -20, -50, etc., and then your right bank positions as well correspondingly. And then you can scroll through and you can see for each position of those Phantom, or I'm sorry, leaf edges for the picket fence, the results and the actual positions. And again, the extremities, outer bank positions of the leaves are pretty typical to have a little more error or a little more issue than the center ones, because they're not quite used as much. But anyway, that's kind of what you're seeing there. You have your results. So that's kind of a quick overview of some of the interface within PIPSpro. Again, everything is fairly automated to give you the results quickly and easily. The memory in the software will take you right to the correct directory where your images are storehoused, and you can go from there. So I'm going to jump back over into the PowerPoint real quick. I've got a couple more slides to show, and then I'll let you get on with your day, morning, afternoon, what have you. So hopefully, and that is a misnomer because we're coming soon at 5.9, which let's see, where's my? But as I mentioned, we have our direct upload into what we call QA Pilot. And you'll see here a little different on our dashboard, as I have here the QA Pilot portal check marked here. And you'll see the ability now, instead of showing you they'll still show you all the tests, but now you have the ability to select what tests you want to have pulled automatically right into QA Pilot. So here I've got my different test results. I can go ahead and pick and choose what tests I want to push, and from there I will go into QA Pilot. It will give you a quick overview there. So I've got my imaging tests here for my cone beam, my contrast, my distortions, my noise, uniformities, etc. Got my draw position indicators for my mechanical, my multi-leaf collimators. So you've got all those different tools there, results to see. You can do longitudinal data, so you can actually see your specific tests, your microcomb beam contrast test. And then you can also do, provide full reporting from QA Pilot as well, for your audits and your accreditations and needed results on reporting. So you have that functionality very easily as well. If you're interested in taking a look at QA Pilot, feel free to reach out to sales@standardimaging.com, and we can set up a webinar on that, and we can walk you through the QA Pilot, or keep an eye out on the website. We do occasionally have scheduled QA Pilot demos as well as most of our products. We have Adaptivo, our patient QA software, our Lucy Phantoms. Pretty much, every week or so we do a webinar at the same time on a Thursday that you can sign up for and attend, and whole host of different products. So, but again, the PIPSpro advantages, everything is quantifiable. There's no qualitative results. Everything is calculated and analyzed quantifiably, and it gives you those repeatable results. Gives you the ability to assure that all the Linux systems are functioning well across. So it allows you to catch those system degradations before it becomes clinically significant. It's got a centralized database that's scalable from your large facility groups to the small single LINAC, 2 LINAC individual facilities. The results dashboards for a quick single view of the most recent results. Quantifiable results for every test with Precision Phantoms available. We've got a Phantom package as part of the offering. Very intuitive user interface for each component. Quick, 1 or 2 clicks gets you right to where you need to be for your analysis. Locates automatically fiducials and field edges, again for less mouse clicks, giving you faster access to results and trending. And again, over 30 TG142 tests in one package, and it automatically has that upload to QA Pilot as well. And the QA Pilot again is a cloud-based system for QA management. Recent updates, we released version 5.8 earlier this year. We added functionality to import and analyze the iRay-based imaging systems from the CyberKnife, from the latest iteration and generation of the S7 CyberKnife. We added the imager to our selections for the imager and the pull-down menu to set up the CyberKnife easily in the system manager. And then we also added functionality of the import for the updated trajectory files that Varian had updated with their latest DICOM image headers, their DICOM headers for the latest iteration of their software. And then coming soon, about 2 years ago, we had purchased a Phantom company called IMT. They've got a number of different Phantoms, from stereotactic Phantoms to MR grid Phantoms to this one here, which is a CT SimCheck Phantom, which allows you to do not only mechanical but also imaging tests on the CT simulator. And we'll be adding QA analysis and trending to PIPSpro for this specific Phantom, and then more Phantoms down the road too. So we're constantly updating and adding to PIPSpro for future use. But it's a very easy Phantom to use with PIPSpro. It'll give you, again, like I said, Hounsfield uniformity. It'll give you it'll allow you to test your mobile lasers, your moving lasers for the CT simulator, the registration and alignment of the CT. So there's a whole host of tests that can be easily done with the CT SimCheck Phantom, and that's available now. And the software should be available, looking at first quarter of 2025 for release for that version 5.9. But other than that, that's kind of what I've got for the presentation today. I think I'm going to check and see the questions now. Looks like we may have one.
Yeah, it looks like we have a few here. I can read some off to you. Yeah, we'll just start here. Someone had asked, once you load and save a data set like CapFan 604 analysis, can you delete that data set if you don't want it within the charted historical set or only archive it?
Yeah, you can pick and choose what gets trended, so you can do both. So if you have a set that you don't want to be part of the trending, you can kind of what we call hide that data set or that result. But it's going to still be there, but it'll be archived, so it's not gone, but it can be put aside.
Awesome. And then also for the dialog box, when prompted to import a CBCT scan dataset, can you add the ability to resize the prompt window size to select the folder path is limited with the current prompt window size?
That's a good question. I've got to check on that, and if not, it's definitely something we can incorporate. So that I'm not sure. If you want to send an email, Alex, to sales at Standard Imaging, and put my attention on it, Hugh Peterson, I will check into that for you.
Awesome.
And I do see you're planning to upgrade to TrueBeam 4.0 in January, and the log file analysis is compatible with the newer system. That came as part of an update to version 5.8 of the software, which is available now.
Awesome. And I think we had one more in the chat from Adam. It says, with an Elekta Versa HD, is there a way to have the gantry table call information come over with the EPIT images to import? They said they're having to manually import those right now.
That's another question. I'm not quite sure. I can check with our customer support, but I think as part of the DICOM, it does have the table and gantry angles set and does come over, but I can double check on that. So again, also if you want to email sales at standardvision.com with that question and your email address, I can find out specifically for that and let you know.
That looked like all I saw. Thanks.
All right. So with that, I thank you for your time, and please feel free to reach out with those questions, and I'll address those accordingly. Otherwise, I want to give you back to your day, evening or afternoon, and thank you very much for your time.